People have been arguing for centuries that 0.9 recurring can't equal 1. This might be because we can produce a pretty good argument against any proof that 0.9 recurring equals 1. And we will examine one of those arguments now. The supporters of real numbers restate their intuitive argument as a formal proof that has been accepted by the mathematics community at large, and so they'll claim it can't be argued with. For them, it is an undeniable proof of equality. The formal proof starts by assuming that 0.9 recurring and 1 are both constant values, and then if they are not the same value, then there must be a value between them, which we'll call x. But as disbelievers with the arguments we've made earlier, we've already established that 0.9 recurring can't be a constant value, and so by rights we should be working with series, not with fixed values. And so our version of their argument is that if 0.9 recurring and 1 have different series, then a series can fit between them, which we'll call x ... In the formal proof, they consider the sum to the nth term, and they claim that all nth sums are less than 0.9 recurring in its entirety. Whereas working with series, we can say that the nth sum of x ... should be between the nth sums of 0.9 recurring and 1. In the formal proof, they use the fact that the sum to the nth term is a distance of 1 over 10 to the power n away from 1 to deduce that 1 minus x must be between 0 and 1 over 10 to the power n. But if we use the same fact when working with series, we can deduce that 1 minus the nth sum of the x series must be between 0 and 1 over 10 to the power n. In the formal proof, the muddled logic continues with the idea that 1 over 10 to the power n can be replaced by 0. Therefore, 1 minus x must be less than or equal to 0, thus proving that any value we try to place between them must equal 1. Therefore, they must be the same value. Whereas with the series approach, we can find as many series as we like between 0.9 recurring and 1, such as 95 over 100 plus 45 over 1000 plus 45 over 10,000 and so on, which happens to be exactly halfway between 0.9 recurring and 1. But they will insist that their proof is still valid, because a proof is deemed to be valid regardless of whether or not the premises or assumptions are valid. Just try to get your head around this. It doesn't matter if we wrongly assume that 0.9 recurring is a constant, because the proof that it must equal the constant 1 will still be valid regardless. Finally, thank you for taking the time to watch, and I hope you enjoy my other videos.